Try multiplying 0.1 by yourself over and over again. 0.1 to the power of n go to 0. But what about this one? Would it also become 0? The exponents stack up like a tower, so this is called a power tower. Let's calculate a few steps to get a sense of what's going on. Let x1 be 0.1. x2 is 0.1 to the 0.1. This comes out to about 0.7943. Surprisingly, it jumps to a value much larger than 0.1. Now, we take 0.1 to that result. x3 is approximately 0.1606. This time, it drops a lot, but it is still bigger than 0.1. So, what happens next? Let's keep going and list the values up to x10. Unexpectedly, the values don't just keep decreasing. At some points, they actually increase. And then they drop again. Even though this back and forth continues, the jumps get smaller and smaller, and the sequence is approaching some number. That number is definitely not 0. We need to find that number more rigorously. We are gonna call the value of this power tower y. Focus on this expression. This is also an infinite power tower of 0.1. This entire expression is also y. So the original problem can be rewritten as 0.1 to the y equals y. Now, take the natural logarithm of both sides. Our task is to solve this equation for y. The equation doesn't look very complicated, but in fact, it can't be solved using elementary methods. This is the moment we call it reinforcements. Its name is the Lambert W function. The Lambert W function is designed for equations of the form y equals x times e to the x, where the variable shows up both outside and inside an exponential. It acts as the inverse of this expression. This is the graph of the Lambert W function. The two graphs are symmetric about the line y equals x. If y equals 10, the Lambert W function tells you what x must be. By definition, x, that is w of 10, is approximately 1.7455. You can use specialized calculators or computer algebra systems to evaluate values of the Lambert W function. In practice, the Newton-Raphson method is commonly used to compute it numerically. Now, let's rewrite our equation in this form. First, divide both sides by y. Since y equals e to the ln y, what if y equals e to the negative ln y? Multiply both sides by negative 1. Let x be negative ln y. Now, we have exactly the form of x times e to the x. Eventually, we can apply the Lambert W function. X negative ln y equals w of negative ln 0.1. Plug in the numbers and simplify. Y is approximately 0.39901. This value is not 0. It's even larger than 0.1. It's completely counterintuitive. Once again, the infinite world turns out to go far beyond our intuition and imagination. Infinity is smiling, but your intuition is already in trouble. So stay connected with math travel.